Hi, welcome to another video on my Arduino Mega2560. So far I have put some 4 motors via my breadboard with electronics, and by programming, as you can see this, I have tried quite a few things. What I have done so far is some measurements, apart from voltages, on pulse width modulation. As you can see here, output value 1 through 5 have something to do with pulse width modulation. And if I go to the web page about the Arduino, you can see it says all pulse width modulation. Here's the pinout, and here it starts pulse width modulation, then some more pins with PWM, and here it continues. So, although this is C, it is embedded C, adapted to the Arduino, which means also that I can't just do input to it. So whenever I change it, I have to put it hard-coded in here, upload, and then see what happens. So what I want to do now is, regarding these output values, again 1 through 5, and then see what frequencies I actually do measure, and then I should be able to see that this one is the half frequency of this one, and this twice the frequency, and this is the same thing. So looking at this one, pin 3, 4, 5, 3, 4, 2 and 6 are corresponding to the various output pins, and I should be able to measure on output pin 3 output value 4. I see that I have put everywhere output value 4, so I should be able to get the same value on pins 3, 4, 2 and 6. And I think it is a nice idea to change those after that into, for example, output value 2 and 1, to see if those are going to be changed. And I can of course use the serial monitor to check things, but yeah, well, this is for another test. So let's just start measuring the values on the outputs. So to measure the pulse width modulation frequency on those ports that I found, I have to look at this side, and those are 2 and 3 and 4 and 6 on this side. Of course they are wired. 2 is wired to the red, no, to the blue wire. So what I can do is measure here with the mass and measure here, and let me show you the output of the multimeter. So once again the mass, and this shows 0.5. Since it is a kilohertz, this is 500 hertz. Then 3 is not wired, 4 is wired, and it goes, let me see, 4 is this wire, which goes all the way here. So taking the mass again, and this says, if I'm not completely mistaken, and it looks like I'm completely correct, yes, then it says 1 kilohertz. Then we take 6, which is ending here, and then it ends, and once again the mass, and it ends here at this resistor, and it says 500 kilohertz. So there's a change. Another thing that I notice is that the motors are not working at all. So what I can also do is measuring whatever is going on there, and this is a frequency and not a voltage measurement, and it says 4 kilohertz something, and this one says 1 kilohertz, and here it says 1 kilohertz, not surprisingly. Regarding the fact that pin 7 is also wired, what does pin 7 do? It's also pulse width modulation. So pin 7 goes here to this resistor, and let me find the mass again, and that says 1 kilohertz. Then, which is wired also 8, it's also pulse width modulation, and that is wired here to that is wired here through here. So when I take this one, it says nothing. That is really odd. And now this motor stops. Did I touch something which I shouldn't have touched? Can't imagine. Yes, a power wire. There you go again. Anyway, noting the 500 Hz and 1 kHz values, let's go back to the code and see how I can change those. And once again the output values, and I think these are maximum settings. 1, half, 2, 2 and 1, and here they are all the same. Now one thing is quite nice, and here you see the advantage of commenting what you do, because this is for the one motor and gear. For the circuit with one RLC circuit, a motor and propeller. This is with 3 inductors, and this is with the chain and digital switch I created. So what I want to do is actually saying 1, 2, 3, 4, and that makes no sense actually, because then I have only 3 different values. So what I may do, 1, 2, 3, and say make this 2.5, and then make this actually 1, 2, 3 and 4. And then let's see what happens. So it had all 4, so if 4 which was 2 means say 500 Hz, then it will now be slightly higher, or if this is 1, this was 500, I'm not exactly sure anymore, but anyway, let's just see what happens. So first I have to upload, compile and upload. Again I get a timeout, just like last time. Which I do not like. I am getting a timeout. So this means that I have to actually, well, it does work. Reading signature data. I'm not quite sure what it means. Has it actually done something? I'm just going to check, and if the values are different from the first time I did, I'll have to reset the whole thing, unfortunately. So let's check out. So once again checking all the values with the multimeter. one probe to earth, mass I should say. What does this do? 500. Then this one is 1. Next 500. 7. It's also, oh, that's quite varying, but between 200 and 1 hertz, 1 kilohertz I should say. Very curious, very odd. Then 8 is going all the way here. Three kilohertz, 3.5, and 8, although I measured 12 and I'm not quite sure if that is one of them. But what does 9 say? It's 12 kilohertz. 12 and about between 10 and 12 kilohertz. So are those indeed the values I did? Three. Oh, that's a nice one. I put analog output pin 3, and then pin 4 is half. So when I do it here with 4, am I doing correct? Yes, which is here. It says 1. So a 2 value should be 2, which is and output value 4. 4 is 2.5, which is on 6. So if I measure on 6, which is here, it's off because that says a half. So I'm not quite sure if those measurements are correct, unfortunately. And look in the code. The output value 2. Let's see, output value 3 is on pin 2, which is the blue wire. So right here. And that has output 3 is twice, and that's half, and that's not correct. So I'm not sure why this is, but let me check further, because this is making me very curious. I think a part of the confusing is caused by something I did myself, because this is analog and this certainly is an analog port. This also is an analog port, A7. However, I'm not using this anymore, but I do this. And although I say here analog out, I am referring to pin 6, which is actually a digital port. And these ports are all digital, so nothing to do with analog. So let me go here again. I do say analog write, and that is confusing as well. What if I say digital write? Like there. Here I say digital write. So I will just comment these out, this one at least, and say digital write, and then say now I have to use these values. And then I'm curious what will happen. Same for this one. This is alright with these values. Oops. And that means that it's output value 1 and output value 2. So let me put these out. Now I have only these two. And 3 and 4 are actually 3 and 4, so that is good. And then let me see if I get another output value reading. Let's see what happens then. No error? No error. Okay. But I don't hear anything either. And that's correct, because these have stopped now. And the only one that is going through is motor plus gear and RLC. But those aren't doing anything. So I change my mind and I go to here. Let me, because this one is absolutely working. And this should be something that absolutely works. Motor plus gear and the control chain. So let's see. And this is 1 and 4, so 4 should be 2.5 higher than map or 2.5 lower, considering the fact that PWM the width is is inverse to the frequency, so a low width is a high frequency. So let's see. it's not working. It's not working at all. Okay. Then I change this for now. And it actually is working again. At least I do hear the motors. So that means that this line is not correct and this line is not correct. So analog it is and should be analog right. Simple lesson. Then again, with these values used, still 3 should be these values should be 2.5 different. So let's see what happens. If anything. Yes. So with the new code, or slightly rewritten, you see that this motor works now on top. And let's measure. And here I have a little problem. That should be it. So 3 and 6 should be measured. That's a very good one. 3 is not connected, but let's quickly go to the definitions. Motor plus gear, that is this one, which obviously is connected. But anyway, this is 6 and 6 is here, and when I measure it, it says clearly 500 Hertz. And this one is set here to 9, which is not connected, but let's connect it to 3. That should work, which is right here, connected to here, and that says 500. So those are things that I don't quite understand. Let me measure here. That says 12 kilohertz. And measuring from here to where shall I measure it? On top it says 12 kilohertz. Measuring here on top, .500 kilohertz. So measurements are a little off, and that brings me to the conclusion that I have to see if the things that I have in mind for pulse width modulation are indeed as they are. Measurement is knowledge, and right now I am not measuring the values that I expect, or the ratio that I expect, like 2.5. I don't see that at all. And that is a good start for a next episode. So for now, adventures and experiments on pulse width modulation with the Arduino are just starting and very interesting to see. For now, thank you for watching. Unusual outcomes, and to be continued.